Based on the discussion we have developed throughout this slide deck, we now provide a procedure for sample variance curve fitting. Measure individual samples so as to construct sample means and standard errors at a variety of values of x. Present and justify a fitting function and fitting parameters. Ideally, this step is at least attempted before the experiment. Adjust fitting parameters until the curve hugs the dataset as closely as possible, meaning that chi-squared is minimized for your dataset. This means considering variously adjusted curves corresponding to different parameter values and regarding as your best answer the curve for which it most looks as though the observed data came from the curve. The development and assessment of algorithms that aim to find parameter values that minimize chi-squared is an active area of research. The best fit curve and parameters may vary from experiment to experiment. Jiggle the data points individually, each by their standard error, to calculate sample estimates of the standard deviations of the distributions from which the best fit parameter values were drawn. The fitting parameters we have calculated are our best estimates, given our set of data and our fitting function. How do we know that our best is any good? The following steps provide quality control. If our fitting function is good, then the ratio of the minimized chi-squared value to the degrees of freedom, meaning the reduced chi-squared, is expected to land roughly in the neighborhood of unity. Check whether this is actually the case. Chi-squared distribution tables can be used when it is desired to report a numerical probability value for exceeding a particular value of reduced chi-squared. Finally, plot normalized residuals to determine whether the vertical deviations between the stars and the fitted curve exhibit suspicious systematic behavior. A plot of the vertical deviations, those delta y of stars, each divided by its corresponding standard error, is called a plot of normalized residuals. Ideally, these bars fluctuate above and below zero without any discernible pattern and with a characteristic order of magnitude of 1. If a set of data passes quality control, particularly steps 3 and 4, you may report with some confidence the minimized chi-squared value, the best fit parameter values, and the sample estimates of the standard deviations of the distributions from which the best fit parameter values were drawn. In this slide deck, we introduced the quantity chi-squared. We introduced curve fitting based on minimizing chi-squared, which is to say equivalently maximizing probability. When we work with fitting functions with the potential to be accurate, the minimized chi-squared value often lands in the neighborhood of the number of measurements minus the number of fitting parameters. The recipe we outlined in this last video uses uncertainties estimated from sample measurements to provide a curve fit. This procedure is sometimes referred to as sample variance curve fitting.